Hi, I'm Kavisha Madurapperuma. So, as my research area is not into supply chain, I chose a case study from SCM Globe website, um, and this case study is on Zara clothing, where the simulation will be done using supply chain guru software, and it is on a transport optimization for Zara clothing. So with that, moving forward to a brief introduction on Zara clothing. As we all know, Zara is a very popular brand around the globe. So here, this Zara was founded back in 1974 by Ahmad Ziao Ortega and his wife in Spain. So their main hub, or as they call it, the Cube, it is situated in Spain. So next, looking into an very high level supply chain model of Zara Globe. Here in the middle, in the box, you can see this Zara Globe Distribution Center, which is the hub or the cube as they call it. So here, in this Zara supply chain model runs as once these fashion designers uh, bring out the new fashion designs, their sketches and all. Most of the time, they get it from the government orders or requests from store managers or upcoming trends through upcoming trend analysis. During different methods, these fashion designers will be bringing out different uh, new fashion designs. So for these fashion designs, the raw materials will be imported from the cube. The cube imports these raw materials from multiple suppliers all over the continent, European continent mainly. So these raw materials is brought to the cube, as I said before. So from the cube, these raw materials will be sent to the clothing factories or the manufacturing plants with the garment designs and the orders. So once these raw materials, the fabric is sent to these manufacturing plants, the clothing factories will be manufacturing these garments, which these clothing factories are situated also in multiple places around the world. So once these fabrics are finished, these finished garments will be brought back into the cube, where these things will be ironed and hung on these hangers and packed ready for delivery. And from the cube only, these finished manufactured garments will be sent into the stores, where the stores, then customers like laymen like us could purchase these products. And the stores are also situated in multiple stores around the globe. So with that, moving into the supply chain model, the aspects that I'm considering when doing this transport optimization for Zara clothing, here mainly I'll be looking into the raw materials, bringing in raw materials from suppliers, giving transporting them into the factories, the manufacturing plants, and back into the cube and to the store manager. Here the process, the high level process is done where the raw materials will be brought into the cube, and from the cube this will be sent into the garment orders, and the cut fabrics will be sent into the clothing factories. And once the production is done, the finished garments will be brought back into the cube, and from the cube only these will be sent into the stores where the end customer can reach it. So that is the entire process that I'll be focusing for the transport optimization through supply chain management. So moving on with that, here's an high level. This is an snapshot of the map for the transportation route in Europe. So like in here with the green arrows, you can see the logistic hub, which they call the cube in Spain, and the trucks. Mainly here, the transportation will be addressed through trucks. So that will be focused to this that would be the aspect focused through transport optimization for Zara clothing. So this is an snapshot of their deliveries, their production lines, their manufacturing and all. So with that, we'll move into the demonstration. So here, as I said before, the simulation, the demonstration will be done using the supply chain guru application. As I said before, their customers are situated in multiple places around the globe, mainly China, Europe, Japan, USA, and Spain. So the longitudes, latitudes, their cities, the countries, all are populated in this table. So next we'll be looking into the sites. Here MFG is known is written for like populated as these manufacturing plants or sites, and SPL for their supplier sites, and the cube, which is the hub, the main hub that I was talking all through the presentation, which is situated in Spain. So here, Africa, Spain, Asia, Europe can be seen as their manufacturing plants according to the case study, and the cube is situated in Spain, as I said before, and their suppliers are from Portugal, Spain, Italy, and Greece. So here the geocode. Here the sites are mapped in green triangles and the customers are mapped in the blue circles. Here you can see how the suppliers and the customers are distributed all over the globe. So with that, there are 12 products populated in the tables, which is named as from design 101 to design 112, because their designs are specifically not available for even in the case study. They have mentioned it as designs. So next, here it's the shipments. Here, as I said before, the shipments for the raw materials, that means from the supplier to the cube is populated, then sending those raw materials to the manufacturer is populated, that means from the cube to the manufacturer and back from the manufacturer to the cube, and from the cube to their customers is populated here in the shipments table. And here in the transportation assets, they own like the trucks they own, the asset availability to which unit, which site, like if they belongs to the cube, and the ratings for each available transportation asset is mapped here. So here, as you can see, customers, sites, products, shipments, transport assets, asset availability, and rate tables are populated for this transport optimization under the given case study. So with those data, let's run the system uh, transport optimization problem. So here the selected technology will be transport optimization, and the selected problem is also transport optimization. The model horizon or the date range is given according to the shipments, as in like bringing the products from the suppliers, doing all the manufacturing and send them back to the cube and to the customers, and this is done for one product order, as in like 2 months duration. So here once you run it, the baseline transport optimization scenario will be running now. It takes time. So now that it is completed, we can view the output tables here right here the output tables where you can see the transport summary table, then input shipments, baseline output shipments, invalid shipments, and unrouted shipments are populated. Here this table is populated as such, the output table, the input shipments, there you go, and baseline output shipments, shipment outputs, and there can be the invalid shipments. I think these are for the shipments outside of Europe, and these unrouted shipments. So that is the end of the uh, problem, the transport optimization as given in the case study. And thank you.